So we've been talking about graphing inequalities, and now graphing quadratic functions. And so today we're going to talk about how to graph a quadratic inequality, as well as doing some systems, including quadratics. So for inequalities, we need to remember that we draw a dotted line if we have strictly less than or strictly greater than, and then we use a solid line if it is less than or equal to or greater than or equal to. And then we also need to remember that we shade. So if we have a greater than symbol, we are going to shade above, and we are going to shade below if we have less than. And we can't think of inside the parabola or outside the parabola, because if the parabola is opening up or opening down, it changes. So here we have one in vertex form, which means I know what my vertex is. So my vertex is -4, -1, which means I also know my axis of symmetry. It's x equals -4. So I can get started graphing that now. There's my axis of symmetry through -4, and -4, -1 is my vertex. So to get another couple of points, I can use my table. I put my vertex in the middle, and then I use points that are on either side. So -4 to -5 or -3. And then I can substitute these x values to get a y value. So I'm going to use -3, and I'm going to start here. So y, don't even worry about that. So I have -3 plus 4 squared minus 1. -3 plus 4 is 1, squared is 1, minus 1 is 0. So I have -3, 0. And then because of that axis of symmetry, I know I also have -5, 0. Okay, so now let's talk about our line. This is strictly less than, so I use a dotted line. And it's strictly less than, so I shade below. All right, so I use a dotted line. And below, underneath, whatever words you want to describe the less than, these are all the values that are less than that line. Okay, we have another one here that is in vertex form. So my vertex is -4, -3, which means my axis of symmetry is x equals -4. So for my axis of symmetry, I'm going through -4 again. And for my vertex, it's -4, -3. And this opens up because it's positive, so I expect it to go that way. So get a couple more points. I'm putting my vertex in the middle. I'm going to use -3 and -5 again. So if I plug in -3, I've got -3 plus 4 squared minus 3. -3 plus 4 is 1 squared minus 3. That's 1 minus 3, so I get -2. All right, so -3, -2. I use my axis of symmetry to get another one, and I'm going to go with that. So this time, I have greater than or equal to, so that's a solid line, and greater than is above. So a solid line going this way, and above the line is up here. My next two examples are in standard form, so I'm going to have to use my axis of symmetry little formula. So negative b is 4 over 2a, which is negative 2. So I have negative 4 divided by negative 4. My axis of symmetry is x equals 1. All right. Then I am going to substitute my 1 in here to get the vertex. So it's 1 something. So I have negative 2 times 1 squared plus 4 times 1 plus 1. So 1 squared is 1 times negative 2 is negative 2, plus 4 is 2, plus 1 is 3 is what I'm getting. So 1, 3 is going to be my vertex. And that makes sense because the negative out front means that my parabola should open downward. So my next step is going to be to make a table. So my vertex is 1, 3. So x values on either side are 0 and 2. 0 is nice and easy to substitute. So that's going to be 0 times negative 2 is 0. 0 times 4 is 0. Plus 1 is 1. So I have 0, 1. And then I'll use my axis of symmetry, plot 2, 1. And then I can keep going downward. So looking at this symbol here, it's less than or equal to. The or equal to tells me that's a solid line. The less than tells me I'm shading below. So let's compare. In example number 1, I had to shade below. And because this graph is concave up, I'm shading basically on the outside. For this one, shading below is actually going to end up here on this side. So this is why we don't say inside or outside, because it depends on which way the graph is opening. We have to say above or stick with above and below. All right, let's do another axis of symmetry for number 4. So negative b is negative 16 divided by 2 times a, which is negative 2. So that becomes a positive 16 divided by a negative 4. So my axis of symmetry is x equals 16 divided by negative 4 is negative 4. So I'm going to go right here to draw my axis of symmetry. And now I can find my vertex using that axis of symmetry. So if I plug negative 4 into this equation, I think I did that right. I have negative 4 times negative 4 is 16 times negative 2 is negative 32. And here I have negative 16 times negative 4, which is a positive 64, and then minus 34 here. So negative 32 plus 64 is 32, minus 34 gives me negative 2. So there's my vertex, negative 4, negative 2. The negative out front tells me it's opening downward, so it should look like this. So to get us a table, put my vertex in the center. So I'll use negative 3 and negative 5. Negative 3 is the smaller number, so I'm going to use that one. So I have negative 2 times negative 3 squared minus 16 times negative 3 minus 34. 3 squared is 9 times negative 2 is negative 18. Negative 3 times negative 16 is a positive 48. So then I have negative 18 plus 48 is 30. And 30 minus 34 is negative 4. So I should have negative 4 there. So negative 3 down to negative 4 is here. Using my axis of symmetry, I get my other point. And then looking at my symbol, greater than, it's not equal to, so I use a dotted line. And greater than is above. So here's my dotted line. And this time, so last time above was in the parabola, but this time above is going to be this part. Okay, so that is inequalities. Now we are going to talk about systems of equations, and we are going to use some linear, some quadratic. So we need to remember when we're looking for the solution to a system of equations, it's where the graphs intersect. So when we have a quadratic and a linear system, we have three possibilities. So one of the possibilities is, say, I have this, and these do not intersect, so we have no solution. Another possibility is to have the line just touch it barely. That is one solution. And then the third possibility is for that line to cut through that parabola and intersect twice. Okay, when I graph my linear and quadratic systems, I always start with my line because those are very simple to graph and cover the whole coordinate plane. So we must remember, here is my line. I start with my y-intercept at -2 on the y-axis. And then from there, I use my slope. 2 over 1 tells me up 1, right 1, up 2, right 1. And it's very easy to count this out and to get my line because we have no idea where that parabola is going to go and where they might intersect. So I like a nice long line. Now for my quadratic, this is standard form, so I'm going to have to use my axis of symmetry formula, negative b, and my b is -1, divided by 2 over a, or 2a, which is also 1. So that turns to positive 1, and 2 times 1 is 1/2. So my axis of symmetry is x equals 1/2. I'm going to go to the middle here between 0 and 1, and I'm going to draw my axis of symmetry. Then for my vertex, I know the x value is 1/2, and so I will substitute that into my equation to find out what the y value is. So I have x squared minus x minus 6, and I'm substituting this. 1/2 squared is 1/4 minus 1/2 minus 6. And so 1/2 minus 1/4, so that's 2/4. That's a negative 1/4 minus 6. So that's a negative 6 1/4, or 6.25. So my vertex, I go to 1/2, which is where my axis of symmetry is. I'm going to go down 6 and a little further. So down to 6 and a little further, and there's my vertex. And this is positive, so I know it's going to open upward. All right, so let's look at a table. So I have 1/2 and negative 6 1/4 in my table. And so I have 0 and 1 on either side. So let's go ahead and substitute 0, because that's nice and easy. 0 squared is 0, minus 0, 0 minus 6 is negative 6. So 0, negative 6. And then the axis of symmetry gives me negative 6 on the other side. I have not intersected yet, so I'm going to keep going. I have negative 1 and 2. So I'll plug negative 1 in. So I have negative 1, squared minus negative 1 minus 6. So negative 1 squared is 1 plus 1 minus 6. So that's 2 minus 6, or negative 4. So I'm negative 1, negative 4, and look what happens. There's my first intersection. And I can use the axis of symmetry to get the other point. All right. So I have something, but I know if this one keeps going, I'm going to intersect also. So I'm going to keep going, and the next numbers or values will be 3 and negative 2. So let's see, 3 squared minus 3 minus 6. That's 9 minus 3 minus 6. 9 minus 3 is 6, minus 6 is 0. So I have 3, 0, and negative 2, 0. I'm not quite there, but I'm pretty sure 4 is going to give me the value that I want. So let's substitute 4 in. 4 squared is 16, minus 4 minus 6. 16 minus 6 is 10, minus 4 is 6. So let's see, 4 up to 6, and that's what we wanted right there. 1, 2, 3 and a half, 1, 2, 3. And so here is my parabola. And I am looking for this. So when you put your graphs on the coordinate plane, you are not finished, because you have to tell me that the solutions are at negative 1, negative 4, and 4, 6. Let's see what happens when we graph this system. So I'm going to start at negative 3 on the y-axis. And my slope is 1, so I go up 1, right 1. Again, I have standard form here. So negative, or x equals negative b, which is negative 2, divided by 2a, which is 1. So that's 2 divided by 2, or 1. So I'm going to 1, drawing my line, and now I want to find my vertex. So if I plug in 1, I've got 1 squared minus 1 times 2 is 2, plus 1. So 1 minus 2 is negative 1, plus 1 is 0. So my vertex is 1, 0. And that graph is going to open upward, so I have a suspicion of what's getting ready to happen. So I'll go to either side. Plugging in 0 is easy because that gives me my y-intercept of 1. And then my axis of symmetry gives me my other one. And so here is what's happening. Where do those two graphs intersect? They do not. So there is no solution here. All right, for our next one, start at -6. This is a -1/1 slope, so down 1, right 1. Remember, your negative slope should be pointing in the downward direction. If it is not, you are not counting correctly. You're going the wrong way. And so now I am going to graph this quadratic, which, if I'm not mistaken, we've already done. So I'm going to save myself some work and steal my table from the first page, which is right here. So let's see. My vertex is 1, -6, right? No, 1/2. My axis of symmetry is at 1/2. And my vertex is 1/2, -6 1/4. So right here. And then what is my next? I have 0, -6. Oh, look at that. And then I have 1/2, 1, -6. Oh, already did that. And then I have 2, -4. And so that one, right? And so this is what I've got. So what we see is that they have one point that they share, and it is 0, -6. So we have one solution here. Oops. So the last thing we're going to look at today is when we have two parabolas on the same coordinate plane. So let's look at this one first. For my axis of symmetry, I plug in -2 over 2 times 1 is -2 divided by 2, or -1. So my axis of symmetry is x equals -1. And for my vertex, I have -1 something. So what is that something? If I plug that in, I've got -1 squared is 1. -1 times 2 is -2. And then I have -3. So 1 minus 2 is -1 minus 3 is -4. So -1 minus -4 is right there. And this will open up. And I will do the table here. So on either side of that -1 is a 0 and a -2. 0 again gives me my y-intercept of -3. So 0, -3, and -2, or -3. And I'm going to go one more. So if I plug in 1, I've got 1 squared which is 1, plus 1 times 2, which is 2, minus 3. So that's going to be 3 minus 3, or 0. So 1, 0. All right, and we're going to try to see if that's enough points to find the intersection. And I'll go ahead and start graphing this one. So y equals negative x squared minus 2x plus 3. For my axis of symmetry, negative b is negative 2 divided by 2 over, 2 times negative 1. So that's 2 divided by negative 2, or negative 1. We have the same axis of symmetry again. For my vertex, I plug in negative 1. So negative 1 squared is 1 with a negative out front. And then negative 1 times negative 2 is positive 2 plus 3. So that's basically negative 1 plus 5, or negative 4. No, positive 4. Sorry. So I have negative 1, 4 is my vertex, and that one is concave down, opens downward. All right, so I'm going to start a table here with negative 1, 4 in the center. Zero again gives us our y-intercept of 3. So 0, 3, and then that gives me my other point. And then if I go to 1 and negative 3, I'll try 1. So 1 squared is 1, so that's negative 1. 1 times negative 2 is negative 2, and then plus 3. So that's negative 1 plus negative 2 is negative 3 plus 3 is 0. So I have 1, 0, and then I use my axis of symmetry to plot my other point, and I should be finished because I have found 2 intersections. All right, so my solutions are negative 3, 0 and 1, 0. Okay. We have maybe a little bit less work here because we happen to have vertex form for our first quadratic. So I have a vertex of 2, 1, and that means my axis of symmetry is x equals 2. So I'll go to 2, and 2, 1 is my vertex, and that's positive, so it's going to open upward. All right, so let me get a couple of more points. I'll go to 1 and 3. So let's go with 3. 3 subtract 2 is 1. 1 squared is 1 plus 1 is 2. So I have 3, 2, and I can count the other side. And I may as well go ahead and do another one. So 4. 4 subtract 2 is 2. Squared is 4. Plus 1 is 5. So I have 4, 5. Count 2 spaces, and I have the other one. So let's go with this and see if this gives us what we need. When you have an equation like this, you can read it as standard form with a b-value of 0, or you can actually read this as vertex form also with an x value of 0. It depends on how you look at it. I'm going to show you the vertex form because I think you will like that one better. But remember, you can just use a b value of 0 and it'll work just the same. So if I do this way, my vertex is 0, 5, and my axis of symmetry is x equals 0. So here's my axis of symmetry, and my vertex is 0, 5. So I have found a solution already. I think we're going to have another one, though. So here's my table. I have negative 1 and 1 on either side. So let's plug in 1. 1 squared is 1. That's negative 1 plus 5 is 4. 1, 4, and then negative 1, 4. And then I have 2 and negative 2. So if I plug in 2, 2 squared is 4. So that's negative 4 plus 5 is 1. 2, 1, and there's where it goes. Right there. 2, 1, and 2 spaces over is negative 2, 1. So if I graph this parabola, I will see I have an intersection here and an intersection here. So my solutions are 0, 5, and 2, 1.